Hello, in this worked example video, we are asked to find the moments that each of the three tension forces, so I've got tension A, tension B, and tension C, exert about point A. And so point A is where the two beams kind of come together. So I've got two basically wooden beams that are tied together at the central point. I want to know all the moments about the moment that each of these forces exerts about that point. Alright, so we do this one at a time. I'm going to start with the moment that tension A exerts. And so I'm using scalar calculations in this case. This is a 3D problem, but it's fairly simple, so I can kind of get away with that. Alright, so the moment is going to be equal to the force times the distance. Alright, so the force, it's a 30-pound force. The distance, the perpendicular distance, the minimum distance between this force and point A is just going to be this 12 feet. They're perpendicular right there. It's 12 feet. That means that the moment that tension A exerts is going to be 360 foot-pounds. But I can't stop there. I need to label the direction. And so for this, I need to use the right-hand rule and imagine this thing in 3 dimensions. All right, so if I've got point A fixed, I'm lifting up on this side, this whole thing would kind of rotate up this way. And if I use my right hand and I kind of curl my fingers in the direction it would be twisting, I'll notice that my thumb is pointing into the board. So that is the direction of the moment. And so into the board is the y direction. It's the positive y direction in this case. So MA is going to be 360 foot-pounds of torque in the y direction. So 0, 360, 0. The units are foot-pounds. Alright, so that is my moment vector. I've got a force, I've got a magnitude, and a direction. Alright, now I just need to repeat for TB. Same equation, force times distance. And so the force at B's is 40 pounds. The distance is 8 feet. And so the moment, the magnitude of the moment at least, is going to be 320 foot-pounds. Alright. So now if I imagine, again, I'm holding point A fixed, which way would this whole thing rotate? I use my right hand, it kind of rotate up like that. My fingers are pointing in the direction of the rotation, and my thumb is going to be pointing this direction. Alright, and so that's the negative x direction. Alright, so we have MB is negative 320, so negative x direction, 0, 0. And the units are foot-pounds. And so this one was MA, this one is MB. Excuse me. Alright, last one. I've got tension C. I want to figure out the moment, so that M equals force times distance. And that's going to be 50 pounds. And 4 feet. That's my distance from point A, point A to the minimum distance to the force. Alright, so MC, if I multiply 50 by 4, I get 200. I still need to think about the direction as well. So if I imagine which way would this whole thing rotate, it'd rotate the opposite direction from what I had from TB. And so this is actually if I kind of model my hand, the fingers are going in the direction of rotation, my thumb is pointing out this direction, and it's the positive x direction. So MC is pointing that way. Alright, so positive x direction, MC is equal to positive 200, 0, comma 0. And the units again are foot-pounds. So with that, we've answered our question. We've figured out the moment exerted by tension A, tension B, and tension C. Thank you for watching, and I hope to see you again.